Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com.
On the control charts, or SPC, so those terms are interchangeable. Some people call it control charts, or some will say SPC or Statistical Process Control. The main thing is that we're monitoring data in our process and we're tracking it real time, hopefully. And what we're trying to do is see if the data is similar to how it's been in the past. And so what you do is you create a control limits based on historical results. So if the historical results show a certain average and standard deviation, then we would expect if the process is the same, it's going to continue to have the same average and standard deviation over time. Right? So if the average is 50 and the standard deviation is 3, we would expect that that would hold true going forward. So what the control limits do is it establishes probably plus or minus a couple standard deviations, usually about 3 standard deviations up and down from the average. So if it was 50 was the average and 3 was the standard deviation, it would probably go out to 3 standard deviations. So 3 times 3, 9. And so it'd be like 41 to 59 would be the control limits. And based on history, 1 standard deviation is probably like a typical variation. So you might see some 54s, 55s, 56s, 57s maybe. You might see some 42, 43s, 45, 48s, a lot around 50 because that's the average. But you wouldn't see very many out near 59 or down at 41 because that would be fairly unusual. It'd be hard to see that. And so what you do is you plot that data and you check to see if the data points are within 41 to 59. If they are, that's a good sign that you're not seeing anything unusual, but that's just one part of it. The other part of it is picking up trends and shifts. So you could have the data fall within 41 to 59, but it might be all increasing within that range. So it might go from 43 to 44, 5, 46, 48, 50, 52, 53. You get enough of these in a row and the process chart says that's something's going on there. There's some trend or issue happening. That's unusual to see that many in a row behaving like that. So that's what those rules are, is a way to indicate that something's not right, that there's a process change happening or something's going on in your process. Take a look. So these are some of the rules that are in place.
Let me pause for a moment to tell you about our sponsor, Creative Safety Supply. Creative Safety Supply is a great resource for free guides, infographics, and continuous improvement tools. I recommend starting with their 5S guide. It includes breakdowns of the 5 pillars, ways to begin implementing 5S, and even organization tips and color charts. From red tags to floor markings, it's all there. Download it for free at creativesafetysupply.com/5S.
And those rules are there to help identify if the process is consistent and stable. And if you see these rules, it means that maybe it's not. So you check for these different rules, and Minitab and software packages usually have these rules built in so that it can check for it automatically, because it could be hard to check for that if you're just trying to eyeball it. All right, so that's the idea with the charts, is that it allows you to see variability in your process and see if it's similar to what it's been in the past. If it is, then it says our process is still in control. It really just means it's consistent. It may be consistently bad, but it's consistent, or it could be consistently good. The control chart doesn't care whether the results are good or bad. It just says, is it similar to what it's been in the past? So you gather data from your past, you establish control limits, and then you trend the data going forward to see if it starts to deviate from that. And if it does, then it might say something's changing in your process. And then you go investigate it before it becomes a major problem, hopefully early. So it's a great tool for detecting changes in your process as soon as possible. The goal is once we have the process running smoothly, we want it to keep it there. This chart can help us tell us, hey, something's starting to change. Either it could be changing for the good, it's getting better. That'd be great. That's a good thing to know, that your process is trending in the right direction. or it could be trending in the wrong direction. It's getting worse. So it doesn't necessarily say whether that trend is good or bad. You have to understand based on the metric that you're tracking if that's a good trend or a bad trend, or a good shift or a bad shift. So it's usually outliers, trends, and shifts that you're trying to pick up. Right. And so there, depending on the type of data you have, then there's different charts you can use. And so they went through the individual moving range chart, which is the most commonly used one, because you're just plotting individual data points. And then they introduced the X bar and R, which is where you collect multiple data points at the same time in a subgroup. Okay, so depending on your data situation, that may dictate the type of chart you would use. The X bar and R chart is a very powerful chart. If you can do it that way, that's ideal. If you can't, then the IMR, individuals in moving range, that chart can be used, and that works fine. So the cool part is that it's a great tool for getting ahead of problems and finding them quickly. One of the key benefits for all this process improvement work is the ability to find problems quickly and address them when they're small or manageable. What typically happens is when they become so large that they get noticed, it's almost too late. You have a bunch of issues to deal with.
LeanSixSigmaDefinition.com has a list of glossary items about popular process improvement terms, along with a history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ohno, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit LeanSixSigmaDefinition.com.